My name is Paweł Wieczorek. I work with Collabora for 4 years now. I started contributing to KernelCI project in July 2023. And today I would like to share with you what the team has been up to, what is the current status of things, what's still in the works, and how you could benefit from all of it, whether you're a kernel maintainer, a developer, an automation or quality assurance engineer, or involved in these efforts in any way, or just interested in this topic. We will start with a short introduction to what KernelCI actually is. Next, I will describe shortly current status of KernelCI components. We will also take a closer look at how to interact with various KernelCI components and how it can be used by people with different roles in the kernel community. After that, I'll talk about current refinements in the works, and I will also show you how you could try all of it out. Finally, I will share with you some closing thoughts, and we will have a Q&A session. So I realize many of you already might have an idea of what KernelCI is, but just to have a common baseline, let's get a basic idea. When you hear KernelCI, it probably comes to my mind just a simple CI loop with short planning, then building, testing, evaluating results of those tests executed, and then repeating the whole process. This is not far from what KernelCI does, but there are much more aspects to consider in this process. First of all, even though all kernel sources are stored in Git, they are hosted by various services, and not all of them provide an easy-to-use event mechanism that automated systems such as KernelCI could facilitate to trigger proper tasks executed internally. Then there is also the aspect of scheduling access to several types of resources, whether there is a build farm and compute resources required for creating your kernel images, or if that's the specific hardware that you would like to execute your tests on. Also, we need to remember that someone has to process and archive all the collected data and maintain some of the external dependencies as well, whether it's a build environment or execution environment. And taking all of this into consideration, it turns out that this task only seems simple until the scale of the endeavor grows. Also, the fact that the hardware is involved in all of this process does not make things easier. But KernelCI decides that it should stay as easy as possible and create as little obstacles as possible to everyone involved in this process. And the main idea is to hide all the implementation details and do not expose people involved in the development process to all of the complexities of these tasks. Also, simplifying and collecting the common parts of these tasks helps to determine if there are some duplicated efforts in the community, and if so, how to reduce these duplications. But that's that's only a technical aspect of KernelCI as a project. In general, KernelCI is a community engagement project, And this is equally important aspect of this effort, apart from the technical solutions. And now, having clarified that, let's get a better perspective of various KernelCI components and have a short look at their current status. Don't worry, we will dissect this whole diagram in a bit. And going from the top row, you have all the components that you might interact the most as a kernel developer or maintainer. So in the top row, from the left, we've got the kernel trees hosting services. In the middle, we've got the CLI tools that can be used for interacting with KernelCI. And on the right, there's a web dashboard, which probably might be one of the most commonly used tools for interactive use. In the middle section, on the left, we've got the Maestro orchestrator, and on the right, we've got the KCI DB for storing all the results, and storage service for keeping all the artifacts of the process. And on the bottom of this diagram, we've got the labs, the foundation of tests execution in this process, whether they are connected directly to a KernelCI infrastructure, or if they only contribute some of the results through the KCI-DB back to KernelCI. And now let's take a closer look at specific components, starting from the web dashboard, which you might be interacting with the most, and probably it also might be your first contact with KernelCI components. It attempts at providing only relevant information and not overwhelm you with unnecessary data overload. It has gone through several revisions and is still under development. If you see something that might be missing in this interface, please don't hesitate to reach out and let the team know. Dashboard is available at dashboard.kernelci.org or simply d.kernelci.org if you'd need a short link to it. And if we have a way to present the data, although we already have the way to present the data, it's equally as important to get more insights out of the collected data. That's the key in this process. There were several proof of concepts over time, and the best approach is currently being integrated into the web dashboard. But where does the data come from? It's currently stored in KCI-DB, which is slowly being superseded by KCI-DB new generation, which is a test results collector tool. It currently supports data collection from various sources, so not only the KernelCI systems, but also, for example, Zero-Day, Sysbot, and Red Hat's Cookie. It's storage from a single point of truth for results delivery, both for reporting through webboard or finding regressions. And if you have been a user of the former KCI-DB, it is strongly encouraged to migrate to the new API. But now, knowing where the data is stored, let's take a look at who produces it. And All of that relies on the labs where the code is tested. For the long time, KernelCI was bound to Lava-based labs for hardware testing. For quite some time, this is no longer the case. With the refined architecture of KernelCI components, it is possible to extend this setup to also support non-Lava hardware laboratories, and it's no longer a hard requirement for connecting to KernelCI infrastructure. There are currently a few Lava labs connected there, but like I said, if you have other type of laboratory, it is possible to make it all work. And these labs can receive task submissions, but in order to create them, there is a set of small services that orchestrate all of the tasks involved in this process. So instead of having a hard-to-scale monolithic application to do all those tasks, there is currently a set of small services that provide several abstraction layers over those. They have been adjusted to cover cases specific to kernel testing. So there's one for just monitoring trees, for processing all incoming events, then finally scheduling the tasks I mentioned earlier into different labs, whether they are just compute labs for building artifacts or the ones to actually execute tests on real hardware. Also, there are some for result processing and submitting them further, for example, to KCI-DB and G I mentioned earlier. And with all of that in the works, there is also a need to have a storage service for kernel images or other artifacts upload and then downloading them when needed in this process. We've got for it the KernelCI storage, which currently supports the best Azure blobs, since the KernelCI Maestro components are deployed in that cloud service provider, but there are others supported there as well. Finally, there is also a tool to interact with all of those components, which allows not only the automated pipelines that are pre-programmed within the Maestro tool, but also allow you to do some custom submissions with arbitrary commit testing, retrieve all the results either from KCI-DB or from specific system like Maestro. But we will discuss the details of KCI Dev CLI utility later on. If you'd like to have a quick look, go ahead to kci.dev and take a quick peek. To sum it up quickly, just this section, the key points I'd like to highlight once again are the facts that the new system was built with extensibility in mind, and it improved greatly the ability of this system to scale up and also delegate some of the tasks to the external tools that are simply better equipped to perform such jobs. And with the refinement of all the components, there is also there has been dropped a requirement for hardware lab type to be a Lava lab. We have covered what the KernelCI currently is. We have a good understanding of what the tools do we have on hand. Let's take a look at how these tools can be used. And in order to do that, let's take a few roles in the kernel testing or kernel development in general community. You will also notice the chevron indicator in the top right corner, which helps you to see how much of an effort and understanding of KernelCI components is needed in order to run the tasks that we will be discussing. For start, let's take a point of view of kernel maintainers. The main prerequisite is that a maintainer has a kernel tree to take care of, and natural expectation is that that person would like to get all of the notifications of potential anomalies, whether there are some build failures or test failures during the execution, and preferably little to no initial setup to get those. To make use of the current KernelCI infrastructure, there will be three abstractions that kernel maintainer has to get familiar with. And these are the tree and build config. And these are used to point the KernelCI infrastructure to the kernel tree that should be monitored for changes and give an indication of which branches should be built in this process and how to build them. The third abstraction is related to receiving the notifications of anomalies directly from the KernelCI dashboard. And this time it is not configured in the pipeline of the Maestro component, but directly in the dashboard. This way, getting to know only these three tools, you get notified by email about all the failures that may occur. You still can access all the results either through dashboard or through the CLI tools. And it's all at the cost of simple configuration change request in Maestro and in the dashboard. And now, taking up the difficulty level a notch, let's take a look at the kernel developer's point of view. I assume here that the same prerequisites, so working kernel tree, little to no initial setup are still in place for kernel developers. But there is one more assumption I'd like to make, but it's optional. A developer might also need a Maestro access token. And why? We will take a look at this shortly. But the expectation might be to have finer control over what is being run within the Maestro and that some of the test suites or even test cases run by the Maestro pipeline can be adjusted by developers themselves. And here, again, three simple abstractions that developers might need to get familiar with, and these are jobs, schedules, and setting the rules for them. jobs specify all the repetitive actions that are needed to complete recurring tasks. They are typically defined by those simple Jinja templates, and you can have a look at them in the pipeline repository I linked in the basic abstractions. The schedule, however, answers the questions of what should be executed, when, under which circumstances, and where. So the hardware labs and specific devices that should execute those tests. And as I mentioned, if you'd like fine-grained control over when should all of those tasks be executed, there's also the ability of setting rules at both jobs and schedules. On top of that, there's also the KCI dev CLI utility I mentioned earlier, and if a master access token was granted, kernel developer can request jobs for specific commits, not only the top of the tree that is being monitored by Maestro service. Other subcommands of KCI dev also allow you to get a task status directly from the Maestro system, not only what is being sent to KCI DB. This way, you are no longer limited to all the tasks that are set up by default in KernelCI infrastructure. You have also better control over resource utilization with setting all the rules. And like I said, you are now in control of testing the kernel trees at a specific point and not just most recent change. Now let's take a look at the point of view of quality assurance engineer. And I still assume that there might be some overlap with what developer is expected to provide and to have. But maybe a QA engineer also has some custom test suites to be executed in the pipeline. Also, there might be a need to specify some build options or customize build and execution environments entirely. And for that, again, there are 3 more abstractions that QA engineer might need to get familiar with, which are build configs stored in the core repository, as well as Docker image templates for build environment, and the rootfs configs and templates for the execution environments. Once all the changes are done in relevant config files, the artifacts will need to be rebuilt for the future use, but for that there are ready-to-use GitHub workflows in place to either rebuild the Docker images or rootfs images, and build configs are applied at runtime. This way, a QA engineer gets a full control over a task's execution and its environment. And as a byproduct, there might be contributions with templates for others to reuse in their use cases as well. Finally, let's take a lab operator's point of view. And I assume that lab operator has some of custom hardware just waiting to be utilized, but needs to ensure that all of the new hardware works reliably. And for that, that person might need to use some existing test suites, but would like to hand over all of the build and execution environments maintenance. This time, there are only 2 basic abstractions that someone needs to get familiar with, which are the test job templates to get a list of actions that need to be executed on the new hardware platform, and the platform description itself. The third item that a lab operator needs to provide is somewhat dependent on the lab type. If that lab would be just a Lava lab, the third item is simply a token exchange between KernelCI infrastructure team and the lab operator. If the lab type is something else, there may be some more work involved in order to get the new lab working. That's also why the difficulty indicator is switched a bit, because there might not be a need to have much KernelCI knowledge to get started. Maybe it's just a token exchange between infra team and the laboratory, but it's not always the case. And this time it can be as easy as just a token exchange to ramp up new hardware and get some frequently used test suites running on them. And of course, that's putting hardware to a good use. But also there is a layer of control for the lab operators to use if, for example, KernelCI jobs need to be at a lower priority than internal jobs of such a laboratory. The key takeaways from this section I'd like to leave you with is just to start small, try to learn by example from what has already been done in those pipelines, and slowly but steadily build domain expertise in KernelCI project. Still, you might say that that's quite a lot of hoops to jump to get these pipelines running, and that's why some of the use cases are currently being refined. Starting with the build configuration. Instead of having this process too complicated to apply new changes to config, so creating a pull request in the pipeline configuration, then getting it approved, merged, finally deployed to an instance that you'd be interested in using, maybe it would be easier to keep this configuration closer to your code. This approach has been used before. I believe most of us are familiar with GitLab CI files or Circle CI or Travis CI or any CI files kept directly in the code repositories. And this is the basic idea behind the KernelCI YAML file as well. It aims at giving more control to the tree maintainers by allowing to modify all of these configurations on their own. It still requires, however, having a tree listed in the tree file I mentioned earlier. This KernelCI file takes precedence over what has been previously configured in Maestro. So you could say that it's putting much more trust into the hands of kernel maintainers, but we're already running code from these trees. And speaking of putting even more trust in code, there has also been an effort of giving even more flexibility for testing and giving even more trust to people with access tokens granted, and providing an additional pipeline API endpoint that accepts user input with kernel patches directly. This way, they would not have to be merged into a monitored tree before they can be tested within the KernelCI infrastructure. This approach will definitely require some special permissions and maybe even accept lists from lab operators on what can be executed in their laboratories, but then it could result in potential integration with code forges like GitHub or GitLab. The key takeaways from the ongoing efforts I'd like to leave you with is that there are several ongoing efforts that still aim at reducing complexity of these tasks even further. And these tasks and these goals come from the suggestions and requests from KernelCI users, so that all of this infrastructure can evolve and provide more easy-to-use tools. So now we've covered the goals of the project, the tools that are currently available, how to use them, what you can expect next, but what could you do right now? For example, you can try out the managed instances that are provided by KernelCI project, either the production one at the api.kernelci.org or the more bleeding edge integration environment at staging.kernelci.org. You could also try some of the options to set up this infrastructure on your own, either by a guided tour documented on KernelCI docs, or through a semi-automatic way with a set of tools kept in the KernelCI deploy repository. I would strongly encourage you, however, not to go into the deep end of the pool right away. And like I said before, start small, get a better understanding of the components, for example, using managed instances, and then steadily build your confidence and knowledge in KernelCI project. Once you try it out, I would love to hear your feedback. Maybe there are some cases that are not covered yet. Maybe you have some ideas for improvements. Maybe you see something duplicated in the current, in how currently infrastructure is set up, or maybe you have a set of hardware that could be utilized in this way. If you have any comment, please get in touch either by sending an email to the mailing list, hopping on the IRC channel, or going to Matrix. But you might meet most of the development team on our Discord server. There will also be an opportunity to discuss all of these topics in person on Thursday, right after this event. There will be a KernelCI workshop held. And if you'd like to get more details about it, there's an announcement linked in the slides, which have been uploaded to a SCAD page of this talk. And now, just to summarize it all, I wanted to share that the new system is steadily going through a stabilization phase with a few features still in the works. but the strongest focus is on providing reliable test results and only relevant reports for kernel community without overwhelming anyone with too much unnecessary data, hopefully preventing maintainer burnout from increasing or maybe even helping solving it. But what I think is crucial in this topic, when talking about this topic, is that solving the CI needs for the Linux kernel community is not just a technical challenge. In big part, it's also a community challenge too. And that's why it's crucial to make this shift in kernel testing culture and engage the whole community more in these topics. And with that, I would like to thank you for your attention. If you have any questions, I will be happy to answer them. I will repeat the question.
Okay. Do you have any LabGrid-based labs?
Not yet. There is. Sorry. I'll repeat the question for the recording. The question was if there are currently any LabGrid labs connected directly into the KernelCI infrastructure. So currently, there are no LabGrid labs connected directly. There is, however, a Pengutronics lab connected into the KernelCI infrastructure. And as far as I'm concerned, there is, as far as I'm aware, there is an compatibility layer between the Lava interface and the LabGrid lab. Providing such an interface would be a great addition, probably something to include in the refined use cases next time we meet at a similar event.
So I'm actively working on that at KernelCI. So.
All right. Again, for the recording, thanks team for this comment. There is ongoing effort on providing an interface between the LabGrid and the KernelCI infrastructure. That's great to hear.
So how much of KernelCI is hard-coded for kernel development? Can it be used for other projects like Mesa, which also require and hardware testing?
The question was how much of the KernelCI project is hard-coded to kernel development, strictly kernel development. What about Mesa projects and similar? The services that are provided by KernelCI infrastructure are tailored to kernel use case, but there is nothing that would cause any troubles if you'd like to support any other use case. Like I said, the Maestro component currently is just a set of services that serve the kernel testing purpose well, but they could be either adjusted to support different use cases, or maybe there could be a common component extracted out of the currently used services and then incorporated another service into the setup that would support your use case. New use case. I don't see any more questions. If there is anything you would like to discuss, I will be available at the hallway. Thanks again, and have a great event.